All right. So what we're looking at tonight, we're going to be looking at slopes and also functions, the actual definition of a line as a function. But we want to talk about slopes first. So first off, what is a slope? Well, you've probably heard this. It's the idea of rise over run. Now, the way we evaluate this, let's say we have a ramp like so. We think of this going left to right. And as we go left to right, are we rising or are we falling? So when we talk about rise, we mean rise. As we're going left to right, are we rising up this ramp or are we dropping down the ramp? So this here is your rise. And then this here is your run. And that's it. Now, slope, M, is defined as the rise over the run. Now, I'm going to put rise in quotes here because, again, we could actually be dropping as well. And in that case, clearly you're not rising. Or you could say you have a negative rise. If you're just going horizontally across, that's a zero rise. But we can also look at it like this. We can define slope as vertical change over horizontal change. Vertical change over horizontal change. And so the thing here is if you have a positive vertical change, you're rising as we go left to right. If you have a negative vertical change, you're dropping as you go left to right. So let's say we have something like this. So what's the slope as we, say, go up here from the bottom up to the top? Well, if we're looking at this as we go left to right, if you try to go left to right, you're going to hit this ramp and go up. So that means you're rising. So in this case, your slope M, it will be a rise over a run, or 12 over 4, and that becomes 3. Now let's say we have a different situation. Well, again, as we sweep across left to right, we're going to have to start up here. And then as we go to the right, we have to drop down this ramp. And so that means we have a negative rise. Or you could say it's a fall over a run. Or negative rise over run. Just to be consistent. So you have negative 10 over 2 or negative 5. And so that would be your slope. Now, you might be wondering why we use M. It's a French word, monter, that means incline. I think it means to rise up. So like you're going up a ramp, up an inclination. So monter, M. Now let's take a look at another example. Let's bring out our Cartesian plane. And let's say we have a ramp like this. Place the ramp here, have it come out to here, have it go up to here, and there we go. So the points we have, and grab another pen, you have a point at x is 1, y is 1, x is 4, y is 1, and then x is 4, y is 3. So as we go left to right, we're going to end up rising up this ramp. So we need to get our rise and then our run. So what would the run be? Well, take a look. The run means we start at x is 1 and we go to x is 4. So run is 4 minus 1, or a distance of 3. Now for here, our rise, or we can take a look at it here. We're starting at y is 1 and going to y is 3. So our rise is 3 minus 1, or 2. So finally, to compute our slope, it'll be a rise over a run, or 2 over 3, 2/3. And that's it. Now, what this suggests is there's a general formula for a slope. Like what we could have done, we have rise over run. We can think of 2, again, as 3 minus 1. And we can think of this 3 here as 4 minus 1. And the 3, we can call this the second y value. This is the 1, say first or lower y value. Doesn't have to be lower though. And then when we look at the run, we have a first x value that we subtracted from a second x value. Now let me do this. You might have seen this before. I'm going to derive this again, starting from scratch. This is how it works. So let's say we have our ramp. And let's label some points. So that's x2 and y2. This is x2, y1. And this one here is x1, y1. So to compute a rise and run, well, the run, the larger x value minus the smaller. And let's see here, rise, well, the distance traveled, it would be like so. So now we compute our rise over run. And what we get, is rise over run or y2 minus y1 over x2 minus x1. And this is our slope formula. So ultimately what you need, you don't even need this point. If you just know y2 and y1, which we have here and here, and x2 and x1, which we have 2 here and here, we can find the slope between these 2 points. And that's it. So if we want to find the slope between 2 points, we can use that formula. So let me give you an example. Let's say these are our 2 points. What I recommend doing is labeling them. So let's call this the first point. So here's the x-coordinate of the first point and the y-coordinate of the first point. X-coordinate of the second point, y-coordinate of the second point. And this is important because we use our formula. We don't want to mix up our first and second points. We want to avoid doing that. Otherwise, we'll get the wrong answer. Our formula is always going to take this form. It's always going to be that form. And so now we know exactly what needs to go in the y2, y1, x2, and x1. We can just read it off. Now, when we do these labels, x1 and y1 have to be together. You don't want x1 with y2. If this is a 1, this has to be a 1. If this is a 2, this has to be a 2. And vice versa. If that's a 2, that has to be a 2. If this is a 1, that has to be a 1. So what we'll get? And customarily, we bring the negative out because negative divided by positive is a negative. The entire number is negative. And so there you go. That's how you find the slope between 2 points using that formula. Now, let's take a look at something. Let's talk about lines. I guess an intuitive way of saying a line, what a line is, it's a curve that never changes its slope. And so what I mean by this, if you have something like this, but then it does this, then it drops, then it's kind of flat, then it goes up. Here the slope's increasing. If you're walking along here, it feels like you're walking up a hill. Here it feels like you're walking on flat land. Here you're walking downhill, flat land, walking uphill. The slope of this terrain is changing. But with a line, this would be, say, like curve. With a line, special type of curve, whatever slope you start with is the same no matter what. Anywhere on that line, you're going to have the same slope. It doesn't change. The slope here is the same as the slope there. So there's different formulas for lines. And we're going to look at probably 3 ways of coming up with the formula for a line. So let's take a look at this, slope-intercept. The idea is this. To have a line, you need at least 2 points, and really at most 2 points. So let's take a look at this. If I have a point, and I say a line passes through that point, what do you do? Okay, let's give this point a name, call it x1, y1. But is the line going through this way? Is it this way? Is it this way? How's the line passing through this point? How is the line oriented? We need a second point to do that. If we have a second point, well, this locks our line in place. So what we'll get is something like that. So you need 2 points to specify a line. Now, since we have 2 points, and the slope of the line is the same everywhere on that line, if we find the slope between 2 points on this line, well, that means this is the same slope everywhere along this line. So if we could just pick out 2 points and find the slope between those, well, that gives us the slope of the entire line. Now, where slope-intercept form comes in is that one of the points is an intercept. So this is how it works. One of the points that our line passes through is 0, b. This is the y coordinate v. And then it passes through this point. And some other point, x, y. So these are the 2 points that the line passes through. And we're, some point that's just kind of out there, who knows? But we insist that one of the points for the slope-intercept form, we'll talk about other forms of point-slope formula later. We insist in this case that we know the line passes through a y-intercept. So let's compute the slope. So again, let's call this C. Let's say we want to do, I think we want to make this one our second one, this one the first one. In our slope formula, it's m y2 minus y1 over x2 minus x1, which becomes y minus 0, y minus b, over x minus 0. Now, x minus 0 is just x. So we get m is y minus b over x. And what we want to do to get this formula, we're going to solve for this y. So let's isolate it, multiply both sides by x. So if you divide by x, multiplying is the opposite of dividing, they cancel. And so we'll get mx plus y minus b. Add b to both sides, because the opposite of subtracting b is adding b. And so what we end up getting is mx plus b equals y, or as it's typically written, y equals mx plus b. So we can come up with a formula to generate y's if we will know this other information. And see, that's the thing. What we typically do with y equals mx plus b is this is a formula for a line. And so this tells us if we input an x, remember, x is an independent variable. We get to choose it. To figure out the output y, well, obviously we're going to have to choose an x. We also have to have an m and a b. So there's some information they have to give you to make this work so we can generate points. So inputs and outputs. So typically, we're given m and b. We choose x, and then we use these pieces to compute y. And that will give us a coordinate or a point on that line. So how does this usually go down? Well, again, typically we're usually given these two. So for example, let's say m is 2 and b is 4. So what does this mean? Well, what it means, the slope m is equal to 2, and the y-intercept 0, comma b. This is where this line crosses the y-axis. Will be 0, comma 4. So to come up with the equation for this line, we start out with our slope-intercept formula. Or slope-intercept form. We've been given a slope, and we've been given the intercept. Now, they talk about slope-intercept. What they mean by intercept is the y-intercept, not the x. So for slope-intercept form, you don't want to use an x-intercept. You're always going to be using a y-intercept. So they gave us a slope, they gave us an intercept, and our b is going to be 4, and our m is 2. So that means the equation of our line is 2x plus 4. And if we want to generate a point on this line, well, we already have a point on this line. We've got this. Let's generate another one. Let's let x equal 10. Well, then y is 2 times 10 plus 4, or 24. So the point on this line, to go with 0 and 4, is 10 and 24. And interestingly enough, again, if you have any 2 points on a line, the slope between those 2 lines will be the same as the slope between any other 2 points on that same line. Again, they have to be on the line. The points have to be there. But let's compute the slope between this and this. Do we actually get 2? Let's find out. So we have 0 and 4, 10 and 24. So let's call this our first point. So this is x1, y1. Second point, x2, y2. So y2 minus y1, x2 minus x1, 24 minus 4 over 10 minus 0. Well, that's 20 over 10. And sure enough, that's that slope of 2. So there you go, it still holds. Now there is something I want to talk about with slopes here. Sometimes we'll be asked to come up with the equation of the line given a slope and a y-intercept. Or we might be given the equation of a line and asked to identify the slope and the y-intercept. So let's say we have this. Now, the slope is always attached to the x. That's your slope. And you have this y-intercept is the constant. Now, a key thing for this, and there's another form we'll talk about this, but if it's in slope-intercept form, this isn't going to be difficult. The number attached to x, including its sign, that's the slope. The constant number by itself, that's the y-intercept. So you want to make sure for that kind of thing to work, you have to have solved for y. Y needs to be on the other side by itself. Or you might have to solve for y on your own. Here it's already given. So in this case, the slope, m, is 3. The y-intercept, and this is usually described two ways. They might just call it 2 or 0, 2. And remember with a y-intercept, the x-coordinate is always 0. So either way with that one. Now, identifying slope can be kind of tricky. So let me go through some examples here. So something like this. In this case, again, the number attached to x is your slope. M is 5, and your y-intercept in this case is -1. You could rewrite this 5x plus -1, where it's mx plus b. B will be -1. So your y-intercept will be -1. All right. Now let's take a look at something else. Well, here the slope is 2/3, and the y-intercept is 7. All right. And if this was a -2/3, well, the slope is -2/3. This is negative, then the slope's going to be -2. You can have negative slope. Now, let's say we have this. Now, this one could be kind of tricky. It doesn't look like there's a number in front of the x, but the slope is not 0. Remember with variables, when a variable is by itself, there's an invisible 1. Because 1 times x is just x. So because 1 times x is just x, we write it like this instead of writing it like that. But for figuring out slope, you need this form. So m is 1, the y-intercept is 3. Another one like this. Again, there's an invisible one. And the reason is, if you think of -5, -1 times 5 gives you -5. Same thing with x. -1 times x is -x. And so in the same way we write -1 times 5 is -5, we're going to write -1 times x is -x. But to figure out slope, we want to go backwards, use this form. So here the slope is -1, and the y-intercept is +4. So just a few notes on slope. Now let's see, so that's the slope-intercept form. A version of this, I'm going to call it like a third formula, but it's what's called the point-slope formula. And it works like this. Oh, there is one more I do want to show you. One more slope. Now, this doesn't have an x term. It's just y = 8. And there's a way of interpreting this. You can say this is the set of all points where 8 is in the y-coordinate. And what you'll do, if you look at all the points that have an 8 as a y-coordinate, it forms a horizontal line passing through 8. So the way we can look at this in terms of point-slope formula, well, 0 times x is 0. In fact, let me take a step back here. We know 0 plus 8 is still 8. So 0, we can multiply pretty much anything there with 0. And let's multiply, in these terms of real numbers, we can multiply anything with 0 here. And any real number times 0 is 0. So the way we can interpret this is a slope of 0. So m equals 0, and then the y-intercept is 8. So just one more example to show you with these slopes. All right, now point-slope formula. So what we're going to do, we're going to compute this using 2 points. One of them happens not to be an intercept. We insisted that one of the points be a y-intercept last time. Now we're going to consider what happens if neither point that we're working with is a y-intercept. So again, the idea of a line, the slope between any 2 points on this line is going to be the same if we computed the slope between, say, a point here and a point here on the line. The slope here is the same as the slope here. So if we find the slope between these 2 points, we've found the slope that we're going to find all along this line. Well, what is that slope? Well, let's find out. So do some labeling. Well, it's already labeled for us. In fact, let me back up a little bit. Let's do this. Let's not call this x2, y2 just yet. So you have an x1 and a y1, and this could be some fixed point we're going to choose. And then x and y, this is a point we're going to ask our friend to choose. So let's say this could be like 3, 5. Okay. Or probably more like, yeah, 3, 5. Say we do that. And this is some point our friend's going to choose when they come over. But the one thing we know, it doesn't matter where they choose this second point, the slope between the second point and the one we picked is always going to be the same. If they picked a point here, they chose a point here, or here, any pairs of points on the same line have the same slope. So whatever that slope is, we're going to call it M. And so now we'll do some labeling. I mean, this is convenient, x1, y1. Let's keep it that way. And this one by default becomes x2, y2. And we use our formula. Again, that helpful slope formula. And then filling things in, what we have, let's see, y2 is just y. y1 is itself. x2 is x, that point our friend's going to choose. And then x1 is itself. And the way the point slope formula works, we're going to solve for y minus y1. Because ultimately, this formula, we use it to come up with a slope-intercept formula. We'll start with this, and we'll try to come up with that slope-intercept formula where this y will be part of the y equals. This x is going to be multiplied by m. So ultimately, in the end. So to solve for this top part, this is sort of the form. I mean, you could leave it like this. This is actually fine. But this is just sort of what people like to do. For dividing by x minus x1, let's multiply by x minus x1. So these operations will cancel. Division is canceled by multiplication. And so what we'll get, x minus x1 times m equals y minus y1. Or the way you've probably seen it, you've taken algebra before. We'll put the y's first. And then have the m. Because remember, when it comes to multiplication, this times m is the same as m times this. 3 times 5 is the same as 5 times 3. And so this is your point slope formula. So what do we use this for? Well, what ends up happening is our friend, they kind of never show up. So they never choose numbers for x and y. We're going to choose an x1 and a y1, and here's another thing. Someone's going to tell us an m. That's going to be chosen too, actually. So what you could do is if you have a point and a slope, point slope formula, you can solve for y after you've plugged in your point and plugged in your slope, the numbers for those things. Solve for y and you'll get the equation for that line in slope-intercept form. Basically what we're doing is we're trying to find the equations for lines. And we can do it for a special case where we have the line passing through the y-intercept. Or we can do it for a not so special case where there's a line there's a point that's not a y-intercept, and then, well, x and y could be any other point on the line, not limited to the y-intercept. So let me show you how this works, how this usually goes down. So what usually happens is we're given a slope, let's say 4, and say a point on the line, let's say 2 and 1. That's a point. So I have a slope and a point. Well, the slope's going to be m. The point, let's label it x1, y1. And so we plug these 3 numbers into this formula and then solve for y, and that'll give us the equation of a line. So we're going to distribute the 4 here. Add 1 to both sides. And what we get is the mx plus b form of our line. We could leave it like this. This is perfectly fine, but we typically solve for y. Mx plus b is just a more familiar form. It's one people use more often. So adding 1 over here, -8 plus 1 is -7. So that's the equation of the line with this slope passing through that point. Now, a common thing they will do is they will give us 2 points. You have a point and your friend has a point. And you want to ask, what's the equation of the line passing through those 2 points? Remember, to define a line, you need 2 points to do it. So you pick 2 points. Okay, great. So what's the formula of the line passing through those 2 points? And when you have that formula, you can use it to generate more points on that line. You can have an input, an output, put in a different input, get a different output, put in another input, get another output. You can generate all these points that are on that line. So let's say we have this. Let's see here. Let's try for So let's say we're looking for the equation of a line passing through those points. Well, what we need to do is 2 things. First off, we need a slope. We're going to use our slope-intercept form. I'm sorry, our point-slope formula. But you need a slope to use that and a point. Well, we have 2 points we can choose from, but we don't have a slope. But we can actually compute it. If you have 2 points on a line, you can compute that slope. So that's the slope. So now we have a slope, and to come up with the equation for the line, which point should we use? Well, you can use either one. You could use this slope and this point, or the slope at that point. Either way, you'll get the same answer. Since this is labeled x1, y1, and there's an x1, y1 in the formula, okay, I'll just use that. So I'm going to replace the x1, the y1, and the m, but I'm going to leave the x, leave the y. Add 1 to both sides, and we get y equals 3x minus 5. All right. Now, let me just show you. Let's say I did use this point instead. So instead of y1, I used y2. Instead of x1, I used x2. It will still work. So distribute the 3. Add 4 to both sides, so negative 9 plus 4 is again minus 5. We get the same answer as before. So there you go, point slope formula. Now let's see here, some other things that do come up. The other form of the equation for a line is what's called standard form. And typically what happens with standard form is you're going to usually convert it to slope-intercept form. So standard form is like this. So, for example, you might have something like this. So here your A is 6, your B is 3, your C is 9. They want you to do is, let's say, put in slope, intercept form. And that's y equals mx plus little b, little b. So basically what you do is just solve for y. So we have 6x plus 3y plus 9 equals 0. Subtract 9 from both sides. 6x plus 3y is negative 9, because 9 minus 9 is 0. 0 minus 9 is negative 9. Subtract 6x from both sides. 3y is minus 9 minus 6x. Finally, divide both sides by 3. So we divide this entire side by 3. We're dividing this entire side by 3. That's going to mean any terms that are added and subtracted together, like negative 9 subtract 6x, or if it was negative 9 plus 6x, terms that are separated by plus and minus signs, each of those types of terms are going to be divided by this 3. So what we'll get is negative 3 subtract 2x, or making it a little more like that, y equals negative 2x minus 3. And that's how this standard form looks, as slope-intercept form. And our slope is -2, our y-intercept is -3, or 0, comma, -3. All right. Let's see. Now, the other thing they mention, these are sort of special lines, but horizontal lines and vertical lines. These are of the form y equals b. Or as we saw earlier, you could think of this as 0 plus b, or 0x plus b. So these are lines with a slope of 0 and a y-intercept of b. So how do we know these are horizontal lines? Well, what y equals b means is this means a set of all points with y-coordinate, I'm going to abbreviate coordinate, y equals b. So to put this as sort of a set, it's all points x comma b such that b is a real constant. In other words, we're going to choose b once and for all, and all those points together. Now, x can change. X could be anything we want it to be, but b has to be fixed. So what does this look like? Well, what it is a horizontal line. So let's say we do this. For example, line y equals 2. Well, what's a point on y equals 2? Well, it's any point with a y-coordinate of 2. So pick a point with a y-coordinate of 2. And one that comes to mind for me is 0, comma 2. Now, what's another point with a y-coordinate 2? Well, let's say we choose 4. For x, 4, comma 2. That's another point with a y-coordinate of 2. And remember, for a line, you just need 2 points. We have 2 points, so let's connect these points. That'll give us the orientation of our line. And there it is, a horizontal line. So another thing to take away from this, a slope of m equals 0, that's a horizontal line. And you can also come up with this by computing the slope. Make this x1, y1, x2, y2. If you calculate the slope, sure enough, you get 0. So horizontal lines have a slope of 0. Now, there's another kind of special line, and that's the vertical line. So just to summarize, for a horizontal line, I'll call it an H line. The slope, and this is for, say, y equals b. The slope is 0, and the y-intercept is 0, comma b. Just like in that previous line for y equals 2, one of the points that that line passed through was 0, comma 2 on the y-axis, or the y-intercept. So for y equals 2, 0, comma 2 was there. For y equals b, 0, comma b is there. Anyway, so for vertical lines, these are of the form x equals a. And what this is, it's the set of all points with the x-coordinate, x equals a. Now the y-coordinate can be anything. We can make it anything we want, but the x-coordinate has to be fixed at a. So as a set, it's all the points a comma y, where a is a real number, it's real, and constant. When it's chosen, it doesn't change. But y, on the other hand, we can make y any real number we want. We can just change it however we want. You can even add this. We could have added this for the x coordinate in the previous definition. Put a comma in there. Y is any real number. In the previous definition for the horizontal line, we would add b is real and constant. We have that already. But then you can go back and add x is any real number. Again, for the horizontal line, x could be any real number. But for the vertical line, not the case. Vertical x is fixed and constant, and it's y that can be anything we want. So let's see what that looks like. Take a look at x is 2. So this is the set of all points with an x-coordinate of 2. So what's a point with an x-coordinate of 2? And for me, one that comes to mind, you can pick one. But I'm going to go with 2, comma 0. Remember, the x-coordinate's the first point, or the first number. So 2, comma 0. And we can choose another point. Like, let's say we want a y-coordinate to be 3. Well, the x has to be the same. So we get 2, comma 3. But the y-coordinate, we can make that whatever we want. And we've got 2 points. So let's connect these 2 points to make a line. And sure enough, we get a vertical line. Now there's something interesting about this. It never crosses the y-axis. So vertical lines, there's a rare exception to that. If your vertical line is on top of the y-axis, well, then it intersects every single point on the y-axis because it's literally on top of it. And the one vertical line that does that would be x equals 0. There's 0, that line would sit on top. But except for that one, except for x equals 0, there's no y-intercept. So this is a line that does not have a y-intercept. There's also something peculiar about this. What about the slope? You see, we talked about positive. Your slope we'll summarize this later, but positive slope slants up like this. Negative slopes will slant down like that. And a flat slope is a slope of 0. But what about a vertical line, up and down? Well, let's figure it out. x2, y2, x1, y1. And right away you see what's going on. Division by 0 is undefined. So vertical lines have an undefined slope. So these are peculiar, with the exception of x equals 0, when x is right on top of the y-axis. Excluding that, vertical lines won't have a y-intercept. They're going to have an x-intercept, but not a y-intercept, and their slopes are undefined. So to summarize this, I just want to talk about slopes and sines. So this is sort of generic, but if you have a line like this, your slope is positive. Positive slope line looks like that. If you have this, well, this is when you have a negative slope. If it's perfectly horizontal, like y equals b or y equals 2, your slope is 0. And finally, if you have a perfectly vertical line, this is perfectly horizontal, let's say when we have perfectly vertical, like x equals a or x equals 2, your slope is undefined. I've seen it described as a slope that's infinite, but algebraically, we're going to stick with undefined. So that's it. If you have any questions, let me know. Other than that, have a wonderful evening.